students. In this video lecture we are going to learn how to draw the solid's front and top views when the solid is resting on HP and its axis inclined to VP and parallel to HP. So in our problem set, this is coming under the chapter 2 in projection of solids, axis inclined to VP and parallel to HP. The first question is, a cylinder of base diameter 50 mm and axis 70 mm is lying on HP on one generator such that the axis is inclined at 30 degree to VP. So this is the question and let's solve it. Here the exact case is our solid is a cylinder. That cylinder is resting on HP by its generator. See, when a cylinder is simply lying on the horizontal plane, then it can rest by one of its side generator only. There is no side edges or base edges are present in the solid. So the cylinder is possibly resting on HP by its side generator, and the meantime the axis is inclined at 30 degree to VP, 30 degree to VP and parallel to HP. Just imagine, when a cylinder is simply lying on the HP, automatically its axis is being parallel to HP, and in this case the axis is inclined at 30 degree to VP. So this is what the question. So like the previous problems, here also we needed to finalize where should be the base view is available. So let's start from the problem with our XY line. Then we have to decide from which view we can start the answer. Generally, in all the projection of solids problem, in the change of position method, we need to start the answer by drawing the base view of the cylinder. Here your solid is a cylinder. The base view is nothing but a circle. The circle is nothing but the base view of this cylinder. So this circle should be drawn whether in front view or top view. This has to be decided first. See, just to see the condition here. The solid is resting on HP by its side generator. That is, the solid is simply lying on HP. So as per our regular procedure, we needed to make the axis perpendicular to any one of the principal plane in order to see the base of the solid. So in this condition, the solid axis is parallel to HP and inclined to VP. So we can make the axis perpendicular to VP in order to see the base of the solid in the front view. Instead of making the axis perpendicular to HP like the previous cases, we can select the axis can be made perpendicular to VP. It's easier to view the base. So we can start the answer from the front view in this problem. So in the front view we can draw a circle as a base view. And that circle should be touch the XY line because the solid is going to rest on HP. So here the base view should touch the XY line. So whenever you are trying this answer in the answer sheet, you have to assure the circle should contact the xy line just like a tangent. Okay, the xy line should be the tangent for the circle, but in this computer platform I can move it after drawing itself, but you have to do it well in advance. And as usual, you need to split it into 8 equal parts. Mark the generator points. It's a cylinder, so both base and face points we can mark. I am considering the face is nearer to the observer, that is, in this condition the solid is staying on HP in this way. Okay, now we made the axis perpendicular to VP and parallel to HP. The nearer face is considered as the top face of the object, and the far away is considered as base for our convenience. So if you consider like that, the numerals are coming very nearer to you and the alphabets are far away from you. So in this way we have to give the names starting from A, B, C, D, E, F, G, H, and similarly 1, 2, 3. Sorry, everything has to be mentioned with the dash since it is a front view. 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, and the alphabets are going inside the bracket. Yes. Now we have to project each and every point in the base view towards the top view. Now you can proceed with the top view. Top view is nothing but the lateral view of the cylinder. It's simply like a rectangle. I need to estimate where to start the lateral view. It's my convenience only. I can start from this distance approximately below the xy with some meaningful distance. You should not go for too far or too close, and have some nominal distance. It's your choice. So starting from this point, the axis height given in this problem is 70 mm. So at the span of 70 mm, we can complete our lateral view. It's a cylinder, solid of revolution. So the extreme generators should be darkened and the interior generators you need not to darken. And we can name the each and every points in the base and face. So based on the names we have given in the front view, starting from A, B, C, D, E, F, G, H. And here, when you look from the top, 1, 2, 3, 4, 5, 6, 7, 8. Yes, now I have completed the lateral view, that is the top view here, and you need not to highlight the axis because we are giving priority to the generators here. And then the next is you have to draw the actual position of the solid by considering the angle of inclination given in the problem to the axis 30 degree to VP. Not like the previous questions, here we need to tilt the lateral view which is available in the top view in order to give the final position. For that actually I am in need of extending the XY line somewhat higher. For that, first I am in need of drawing a pilot line at the inclination of 30 degree to VP in the top view area. And now I need to redraw this lateral view once again with the axis inclined at 30 degree to VP. Now I once again drawn the lateral view here. You can note one thing. Here I maintained a little distance between the extreme point of the lateral view and the XY line. I maintained some distance. Why I maintained this distance instead of touching the XY line is, in the previous cases the solid is made to rest on the HP, but here the solid is made to rest on HP already in the front view. If you touch this lateral view with the XY line in top view, what it will mean that the solid is touching VP, but it's not given in the problem. The solid is not at all touching the VP, it's touching only the HP. So in the lateral view, whenever you are going to draw the top view for this, you need to maintain a small gap between the lateral portion of the solid and the XY line in the top view area. Now as usual, you have to project each and every point in the base and face towards the front view. And then from the previous front view also. For the point G and G dash and 7 dash, the projector will come along with the XY line, so we need not to highlight it once again. And now identify the cut points, starting from the base point, that is A, B, C, D up to H. Here I can mark the final A dash, B dash, C dash, D dash, E dash, F dash, G dash, and finally H dash. The same way for the face, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. And then as per our old rule, we can complete the projection. The first rule is to join all outermost points as visible edges. It's actually a solid of revolution cylinder, so we can call as curves. And then how to join all remaining face points as visible edges or curves. And the point 3 is we have to join all remaining base points as invisible curves or edges. And number 4 is for lateral edges. And here, by following the first rule, we have to connect all the outermost points as visible curves or edges. So joining the outermost points as visible curves, the portion G dash up to C dash is a curve portion, so I need to connect it with the smooth curve, and the portion C dash to 3 dash is the generator, so you have to connect it with a straight line. And then from 3 to 4, 4 to 5, 5 to 6, 6 to 7 again curve portion, and 7 to G is again a straight line since it is a generator. The first rule is over, and the second rule is you have to join all remaining face points as visible edges. Here the remaining face points are starting from 7 dash to 8 dash, 1 dash, 2 dash and 3 dash. You have to join it as visible. And the third point is join all remaining base points as invisible curves. The remaining base points are G to F, F to E, E to D and E to T. We need to connect them as invisible points. Now the work is over. This is nothing but the projection of the cylinder when it is lying on the HP by its generator, and the axis inclined at 30 degree to VP and parallel to HP. You can try this answer with your proper tools in the paper and bring out the projection. Thank you.